Welcome to the lecture series of network analysis. Here I am going to discuss the important concept from the module 1. So first in the first video, I'm going to mainly focusing on the important theorem, important equations, important concept. In the coming video, I'm going to solve the numerical example. So that's my plan of action. So first and the foremost, these are the topics which I'm going to give a brief idea, especially what is voltage source in the sense practical sources, then practical current source, ideal voltage source, then network reduction using star-delta transformation. Similarly, loop and node analysis with linearly dependent and independent sources for both DC and AC network. This is actually the basic concept I'm going to cover in the module 1. So first of all, I just wanted to convey you the important concept. So you should know about what is a practical sources. So here, before explaining practical sources, you should understand about ideal voltage source. So maintain the constant voltage regardless of load current. Such kind of practical sources are known as, sorry, voltage sources are known as a constant voltage source or ideal voltage source. Remember, ideal voltage source has zero internal resistance. The symbol will be like a circle with a positive negative. This is basically called an ideal voltage source. Okay. Next is called a practical voltage source. It has a small internal resistance. So what you can do is, along with the ideal voltage source, okay, so you have to connect one internal resistance. So you can call like a R internal. So altogether we call like a practical voltage source. So I think you got an issue about, so sorry, you got an idea about ideal voltage source and practical voltage source. If I talk about like a output voltage of a practical voltage source, that will be the like suppose this is my output voltage. Okay, this is my output voltage across like VL. VL is nothing but V minus IL into RS. V minus, this is my IL, and this is RS or RIN. So output voltage is nothing but the supply voltage minus IL into RS. So this is basically called a practical voltage source. So afterwards, so we should understand about ideal current source. What do we mean by ideal current source? Here, the constant current irrespective of the load voltage. Internal resistance will be infinity for ideal current source. While talking about the practical current source, the thing is the internal resistance RP parallel with the ideal current source. Suppose this is my ideal current source, and I should have an internal resistance called RP, which is parallel to the ideal current source. Sorry, parallel to the ideal current source, so that it become practical current source. We call like a practical, okay, practical current source, practical current source. Output current slightly varies with respect to the voltage, and this is the equation for calculation of the IL. So we are actually applying the current division formula using current divider rule, current current division rule. Okay, using the, because resistance of the opposite branch is RP only, correct? RP divided by R plus RP into I. I means current flowing through the opposite branch. So that is actually called a IL. You can compute by using uh, like a current divider rule or current division rule. So the type of sources, what are the different type of sources available? Similarly, I want to discuss about the independent voltage sources. Voltage or current is fixed, not dependent on the other element in the circuit. That is called the independent sources. Example, battery, ideal current source, etc. all are comes under independent sources. What is dependent? Control sources. The value depending on the voltage or current elsewhere in the circuit is known as a dependent circuit. So dependent circuit, we are going to mark the sources by using this symbol. Voltage control voltage source, that is V is equal to A into Vx. Okay, where A is known as gain. Current control voltage source, that is V. Output is V. V is equal to B into Ix. Do remember this. Okay, where B is known as gain. Similarly, voltage control current source, I is equal to G into Vx, where G is known as the conductance, transconductance. I is equal to G into X. Similarly, current control current source, like I is equal to beta into Ix, where beta is known as current gain. So these are the important points I just wanted to convey you before solving the numerical example and going in depth about network analysis. Other component is called the source transformation. So the peculiarity of source transformation is, suppose I have a voltage source. I have a voltage source. Then it is series. Series resistance is connected to the voltage source. The thing is, what I can do for the sake of simplicity, so draw the current source. Okay, current source, the parallel to the resistance, because we are not changing the value parallel to the resistance. So this rule is known as a voltage transformation. Okay, voltage to current transformation. Similarly, current to voltage also can convert. For example, a current source, the parallel with the resistance is equal to voltage source series with the resistance. In this regard, I wanted to give the relationship voltage source V is equal to I into R. Replace the current source I is equal to V by R in parallel with R. Current source I is equal to V by R. Okay, so replaced by voltage source V is equal to I into R, then selfie with sorry, series with R. So this is regarding voltage source and current source. So try to understand what is ideal current source and ideal voltage source. Okay, so practically speaking, there is no ideal current or voltage source existing. All are like a practical source only. Why? Because we'll be considering like all the parameters accordingly. Fine. So next is actually for the sake of simplicity, we are studying the star delta transformation because we want to reduce the complex network into the simple form. So directly we cannot simplify. So we should have some rules. Those rules will not be affected. So kindly try to understand. So star to delta. Suppose I have star. So I just want to convert the star into delta. So this is my delta and this is my star. So you have to convert the star into delta. Okay. So for example, we can say like R1, then R2, R3 are the star resistance. Okay. So corresponding delta, we can calculate like AB, RAB, RAB. So if I want to calculate RAB, okay. So RAB, so you can mark the terminal A, B, you can mark this RAB, RAC, RBC. So for example, RAB, if I want to calculate, okay, so you can use R1, R2. See, R1 into R2. Numerator, no change. R1, R2, R2, R3, R3, R1 divided by in between A and B. That means the like one element is missing, that is R3. You can mark R3. So like that you can write for RAC, RCB, like that you can write. In the form of like a delta to star transformation. So first of all, we have a delta connection. Vice versa, it is just opposite. Like R1 can be written as RAB into RCA divided by RAB plus RBC plus RCA. Similarly, R2 is nothing but RAB, RBC by RAB plus RBC plus RCA, then R3 is equal to RBC into RCA by RAB plus RBC plus RCA. If I go ahead with that, definitely you can convert star into delta and delta into star, vice versa. So everybody supposed to refer this. It's most important topic. You may get a theoretical and like a numerical example. So we cannot have a provision to leave this question. It is most important. Other one is actually called mesh analysis and the node analysis. Mesh analysis is also known as loop analysis. So it is mainly used for determining the like a current loop current inside the circuit. Also like a total current passing through the common element. Okay. So identify the meshes and design the mesh current. Number one. Next is apply the KVL. What is KVL? KVL is nothing but sigma V plus sigma IR in a closed loop equal to 0. Apply and you will be getting the equations. If there are two loops, means there will be two equations and solve two loops and find out the uh, right answer. So simultaneous equations you need to solve with the help of Calci or manual method. If you go for manual method, go for like a matrix method. Matrix method. Cramer's rule you can apply easily. Types of mesh equation. Okay. Do remember this. Similarly, like if there are two loops, I'll tell you one example. So here you need to consider two loops. There will be like two equations. two equations will be the two equations, maybe two unknown. Okay, so you can identify the unknown value of unknown variable by using the matrix method or Cramer's rule. You can apply. Surely you'll be getting the parameters, unknown parameters. Solve the equation and find out. Like there is one example which is already given, loop one and loop two equations. You can solve by using the matrix method if you are not comfortable with any other calci or any other method. Okay. Other one is like a combined DC AC network analysis. Replace the resistance by impedance. Even use the phase representation V is equal to VAB angle like 0, I is equal to IMP angle phi. Apply the same or mesh analysis using the complex algebra. So like for mesh analysis, what you require is mesh analysis, you require KVL. For node analysis, here node analysis, the specialty is you have to mark all the reference node. So the reference node will be always 0. We consider then assign V1, V2 for each node. Then apply the KCL like sum of current leaving at a junction. Algebraic sum of current meeting at a junction is equal to 0. Similarly, express with content using Ohm's law is equal to like V by R. So here, this is actually called a current. Okay, entering and leaving current. The total current meeting at a point is equal to 0. So voltage of A minus VB stand for it may be reference voltage. So VAB minus VBE divided by R1. Okay, identify all the things in terms of like numericals. Okay, so kindly focus on these questions. Similarly, let me like focus on the important equations. Ohm's law V is equal to IR. Then KVL, next KCL, source conversion, star to delta. Okay, this equation you will please remember. Then delta to star. That's also important. Mesh equation and node equations. This equation, if you study, that is more than sufficient for the theoretical part. Let me know if you have any queries related to these topics. I can like redo it again. Thank you.